You know, every now and then, a medical case comes along that feels less like a science lesson and more like a detective story. And this one, well, it starts not with a crime scene, but with a question. A simple, innocent question from a child that ends up unraveling a huge genetic secret. Mom, why do I have so much hair? Just imagine hearing that from your child. That's the question that kicks off this entire investigation. It's such a powerful and honestly a heartbreaking starting point for a journey into hormones, genetics, and the search for an answer that would change everything for this family. So our story really begins with a childhood that seems to be playing out on fast forward. We have a young girl who's showing signs of puberty years, and I mean years, before she should be. It's interrupting the normal rhythm of growing up and, understandably, sending her parents and her doctors on a hunt for answers. Okay, let's look at the actual case file here. Our patient is 8.5 years old, but her body is telling a totally different story. The doctors see what they call advanced pubarchia, but the biggest clue, the real red flag, is her bone age. Her skeleton is developing like she's 10.5. That's a full 2 years ahead of schedule, which is a massive signal that something is speeding up her development. And while an ultrasound showed her internal organs were fine, the physical signs were just impossible to ignore. All right, so with these initial findings on the table, the medical investigation really gets underway. And just like detectives, the doctors have to follow every clue, ruling out different suspects to pinpoint the one single cause behind all of these symptoms. And right away, they have a prime suspect, a condition called hyperandrogenism. Now, that's a fancy word, but it just means there's an excess of androgens. You might know them as male-type hormones, though everybody has them, circulating in her system. This is definitely what's causing the early puberty. But here's the thing. That's the what. The real question is why? Why is this happening? And then this happens. They get the hormone panel back from the lab, and this right here is the smoking gun. Just look at that top number. Her level of something called 17-OH progesterone is almost 79. To give you some perspective, a normal level for a kid her age should be less than 1. This number isn't just high, it's off the charts. It's a massive, flashing neon sign that points the whole investigation in one very, very specific direction. So with that one crucial piece of evidence, everything clicks into place. The doctors have their diagnosis, and what they found wasn't something temporary or something she caught. No. This was something she was born with, an inherited condition that gets to the very core of how the body makes hormones. The diagnosis is Congenital Adrenal Hyperplasia, or CAH for short. Basically, it's a group of genetic disorders that mess with the adrenal glands. You can think of these glands as these tiny little hormone factories that sit on top of your kidneys. They're supposed to be making essential stuff, like the stress hormone cortisol. And what's wild is that in a whopping 95% of all cases of CAH, the root cause is exactly the same thing, a problem with one single crucial enzyme. It's like one key worker on the factory's assembly line is missing, and it throws the entire production system into chaos. So here's how that chain reaction works, step by step. It all starts with a genetic mutation. Because of that mutation, the adrenal gland's assembly line for the stress hormone cortisol is broken. Now, your brain is kind of like a thermostat. It senses the cortisol levels are way too low, so it starts screaming at the adrenal glands, work harder, make more. The glands respond by getting bigger. That's the hyperplasia part. But since they still can't make cortisol, all those extra raw materials get diverted down another assembly line, and they just start pumping out tons and tons of androgens instead. But here's where it gets a little more complex. CAH is not a one-size-fits-all condition. It really exists on a spectrum, and doctors usually break it down into two main types, classic and non-classic. And believe me, the difference between them is absolutely critical. This chart lays it out perfectly. On one side, you have classic CAH. This is the severe form. The enzyme problem is huge. Symptoms start even before birth, and it can cause a life-threatening emergency in newborns. It's so serious that it's often caught on routine newborn screening tests. But on the other side, you have non-classic CAH, and that's the category our patient falls into. Here, the enzyme deficit is much milder. It doesn't pop up until later in childhood or sometimes even adulthood, with symptoms exactly like the ones we've been talking about, early puberty and other signs of high androgens. And this really gets to the heart of it. The quote here says it all. How severe the symptoms are is a direct result of how severe the enzyme problem is, which all goes back to the specific gene mutation. It's a straight line from the DNA code to what the patient is actually experiencing. And that's exactly why genetic testing is so important for these families. So, once you have the diagnosis, what's next? What's the path forward? Well, the goal isn't to cure the genetic condition itself. We can't do that yet. The goal is to manage the effects, to manage the hormones, so that a child can grow up and have a completely normal, healthy life. The whole foundation of treatment is really simple. Replace what's missing. Doctors use glucocorticoid therapy, something like hydrocortisone, to give the body the cortisol it can't make on its own. And this does two amazing things at once. First, it provides that essential hormone, and second, it tells the brain's thermostat to cool it, to turn down the alarm signals. And when that happens, the overproduction of androgen stops. It's all about restoring balance. And it takes a whole team of specialists and a ton of support for the family to manage it. When you zoom out from this one case, from this one 8-year-old girl, you realize it teaches us so much. We can see the bigger picture here and pull out some really important messages for everyone, for parents, for patients, and for doctors, too. So, what are the big takeaways? First, newborn screening is an absolute lifesaver. It catches those severe classic forms right away. Second, for the milder cases like this one, doctors just have to keep it on their radar. Anytime a child shows signs of puberty way too early, CAH needs to be on the list of possibilities. And finally, genetic testing is vital, not just for the diagnosis, but for counseling families and helping them understand exactly how this inherited condition works. And that brings us right back to where we started, with a question. This whole story started with a little girl asking, "Why do I have so much hair?" And it ended with a clear, definitive genetic answer. It just goes to show you that behind every symptom, there's a cause. And behind every cause, there's an opportunity. It really makes you think. If a single gene can completely alter the path of a childhood, what does that tell us about the incredible power of listening, of investigating, and of finding those answers as early as we possibly can?